Okay,
This conference will now be
let us
recorded.
begin. So we were discussing things with respect to the pointers in the previous class. So we started with multi-level pointers. We saw how to go with different levels of pointers and how to create a two-dimensional array, how to access the elements of a two-dimensional array, and how is the compiler interpreting this two-dimensional array. Okay, so all of that we saw in the previous class. Then we started with one concept called as array of pointers. So we had to discuss array of pointers where you are going with multiple addresses being stored on a continuous manner. So we make use of the array of pointers in order to reduce the number of push and pop operations which happens in the stack frame. So whenever you have to pass multiple addresses, so you don't pass the addresses one after the other, so it is just going to increase the number of push operations, and once the stack frame has to get destroyed, it is going to reduce the number of pop operations also. Okay, so if you make use of array of pointers, but if you don't make use of array of pointers, the number of push and number of pop operations are going to get increased. Now, we saw how to store multiple addresses in the array of pointers. Whenever you are trying to deal with same kind of addresses, you make use of array of pointers. So you saw that you can store the addresses of the variables. We can store the addresses of arrays also. And we saw what happens if pointer arithmetic is being applied on array of pointers. So first time, it depends on size of the pointer or size of address. And the second time, it depends on size of the data type. So we saw a few examples in the previous class. Now let us see one more example here. Okay, so here is one example. You see, there are three integers: a with the value 10, b with the value 20, and c with the value 30. Now I have taken array of pointers ptr of size 3, and it is provided with address of a, address of b, and address of c. Now to the print array function, I am passing ptr as an argument. Now coming to the print array function, as we have already discussed, whenever you are passing the array of pointers base address as an argument, you need a second level pointer. Okay. The reason why second level pointer is required is, here in the array of pointers also, you have to dereference twice in order to get the value of a variable. Hence, when the name of the array is being passed as an argument, you need a second level pointer to collect it. So we collected the base address of a array of pointers into a second level pointer variable called p here. Now you can look at the representation. A, B, and C are present in the address 1000, 1004, and 1008. And in this example's representation, the computed is assumed to be of 32 bits. Now, because it is a 32-bit system, I have taken a pointer variable called ptr. So it is an array of pointers where I'm trying to store three integers. Hence, in order to store three integers, we have taken an array, sorry, three integer address. So we have taken a pointer variable here. So the starting address is 4000. Because it is a 32-bit system, next address is stored in the address 4004. The other next address is stored in the address 4008. Now, how much is the size of this array here? If mine is a 32-bit system, how much is the size of the array here? The elements of the array are 3 pointers. So how much is it in case of a 32-bit system? 3 multiplied by 4, how much is that? So it is 12 bytes. So 3 pointers, and each of the pointer is taking 4 bytes, hence it is 12 bytes. But if you go with a 64-bit system, it is 3 multiplied by 8. Okay, because size of each pointer will be 8. So it will be 3 multiplied by 8. Anyways, the consideration here is a 32-bit system. So pointer is having 1000, 1004, and 1008 stored inside it. Now there is a second level pointer variable called p. What happens in this case is, in the second level pointer variable, So I have collected the base address of array of pointers, which is 4000. So P has got 4 bytes of memory allocated from the address 5000. Now here I'm trying to do is star of P plus I. Can you, P of I. Can you tell me what will I get here? That is a loop running for 3 times. But what do I obtain when I do star of P of I? So first of all, tell me how is compiler seeing star of P of I as? Or how is compiler seeing star of P of I as? So star I'm going to retain as it is. P of I will be seen by the compiler as star of P plus I. Okay. So compiler is seeing as star of P plus I. Now P is a second level pointer. Okay. We never wrote the statement for second level pointers with respect to the pointer arithmetic. Let me list that also. So I'm going with second level pointer variable. Now, after dereferencing a second level pointer, what do I get? First time dereferencing a second level pointer gives me what? Consider this example. Yeah, here. So this is a second level pointer. If I dereference the second level pointer, what do I get? Come on. I get an address. So the pointer arithmetic is same as that of the array of pointers. First time dereferencing gives an address. Hence pointer arithmetic for the very first time depends on size of the pointer. After dereferencing it once, if pointer arithmetic is applied again, it depends on size of data type, because after dereferencing it for another time, you end up getting is an integer value. Hence, this is going to depend on size of the data type. After dereferencing, if you perform the pointer arithmetic, it depends on size of data type. Now let us see here. Am I dereferencing before I perform the pointer arithmetic here? Am I dereferencing before I perform the pointer arithmetic here? No. So first I'm going to perform the pointer arithmetic, then I'm going to dereference. So what does it depend on? Size of what? What is pointer arithmetic depend on? Size of? Come on, what does it depend on? So if I dereference, I will get an address. Why is it dependent on data type? I'm performing the pointer arithmetic for the very first time. So it should depend on size of the pointer, or I would say size of the address. So both of them are going to remain the same. Now size of the pointer is 4 in case of a 32-bit system, 8 in case of a 64-bit system. Now look at the output here. Star of P of I will be seen by the compiler as double star of P plus I multiplied by size of pointer. Now first I is initially 0, hence it is a double star of, okay, P is representing the value 4000, I mean address 4000, plus 0 multiplied by size of pointer, because I have taken a 32-bit system, it is 4. It is double star of 4000. What will 1 star of 4000 give? Dereferencing 4000 for once gives me what? It gives me 1000. I have to dereference 1000 again, which gives me the integer value 10. Okay, so this is going to give me the integer value 10 like this. Now, I'm going to get 10 at P of I. So P of I means P of 0, which is 1000. I'll tell there is 10 at the address 1000. Then I will tell 20 at the address 1004 and 30 at the address 1008. Okay, so it is going to print the values of A, B, and C and their corresponding addresses. So this example prints the value of A, B, and C with the corresponding addresses. Look at the output here. And the address need not be what we have taken as 1000, 1004, and 1008 itself. It can be anything. One second. CD 23. 10. Yes, so this is the example. Let me execute this and show you. VCC 006. Okay, I'm executing. You can see 10 at the address this, 20 at this address, and 30 at this address. And what do you think percentage P is going to print? What does percentage D print? Yes, so it is going to print the address in the hexadecimal format. Okay, so it is going to have the address printed in the hexadecimal format. Okay, so that is about the output here. Okay, just give me a minute. So I'll continue in 2 minutes. So I have an important call to receive. I'll continue in 2 minutes. Meanwhile, if you want, you can note this down. Can we continue? Okay, I'm sorry. So I have an important call to receive. Okay, so that was about array of pointers. The next we have got is nothing but array of strings. Now, before I take you to array of strings, what do you mean by strings in general? Before I take you to array of strings, what do you mean by strings? Come on, what does a string mean in general? I think you have learned strings already by now. And you should have been prepared for the test also on strings. Okay, array of characters terminated by a null character. Exactly. So if you are asked to say things with respect to a string, you are supposed to say it as array of characters and specially terminated by a null character. Now, apart from strings, string itself is an array. Now, if I want array of strings to be taken, so how many dimensional array do you think is required? If I have to go with array of string, what dimensional array is required? For a string, there was one dimensional array enough. Now I want array of strings to be taken, for which I need a two-dimensional array. Okay, so whenever I have to deal with array of strings, we have to go with the two-dimensional array. Now, how to declare this two-dimensional array? You already know. So I am going to consider this example here. So let me copy this into the journal. Okay. Now, go with the new sheet. Okay. Now I have taken a character array called yes of 3 rows and 8 columns. So initialized with 3 strings. One is array, second one is of. Okay, array of, then strings like this. Okay, this is array of strings. So I have taken a character array called yes of 3 rows and 8 columns. Now, how many two-dimensional array do how many one-dimensional array do I have here in this two-dimensional array? You know that two-dimensional array is a combination of multiple one-dimensional arrays. Yes, I have 3 one-dimensional arrays. And how much is the size of each one-dimensional array? How much is the size of each one-dimensional array? Yes, so it is 8 bytes. So in total, how many bytes of memory is allocated for this array? It's a character array of 3 rows and 8 columns. So yes, there will be 24 bytes of memory allocated for this array. Now let me take the representation of this array. One second. So here. Okay, now this is one dimensional array. So there are 3 such one dimensional arrays, which is forming a total 2-dimensional array. So this is one, this is another one. Now assume this is at the address 1000, this is at the address 1008, this is at the address 1016. Memory is allocated on a continuous manner. So this is framing first one-dimensional array. This is the second one-dimensional array, and this one is the third one-dimensional array. Now this has been filled with array A, R, R, A, Y. Okay, and terminated with the null character, because everything is specified in double quotes. It will be terminated with the null character. And what about the rest of the characters? So it has been initialized to 0, because you are partially initializing. Rest of the elements will be filled with 0. Then there is of, so O, F of, with a null character, because I have specified it in double quotes. So all of these will be filled with zeros. Okay, and this is strings. Yes, this is uppercase. Yes, T. Okay, R, I, N, G, yes. Okay, and a null character. So this is what the array is. Now assume this array has been declared inside the main function. So where is the memory for this yes allocated? If I have declared this inside the main function, where is the memory for yes allocated? Come on, where is the memory for yes allocated? If I have declared this inside the main function, yes is a two-dimensional array of 3 rows and 8 columns. It has been initialized with this data. Okay. Please understand it is never in the code segment. Arrays will not sit in the code segment. So it is an array with inside which there is array of strings being returned. So memory for this is allocated. Yes is like a local variable to the main function. So memory is allocated in the stack segment. Now, if the memory for the string is allocated in the stack segment, what type of string is that? If the memory for the string is allocated in the stack segment, what type of string is that? Local string. So we have types of the string. Yes, it's a modifiable string. So whatever you have got inside this string can be modified, and hence it's a modifiable string. Now, observe this pictorial representation. Yes is the name of the array. Okay, it's a two-dimensional array. Now, with this printf function, I want to pass for the percentage yes format specifier. I want to pass something to which I have to get array printed as an output. Can you tell me what should be passed as an argument to the percentage yes? What should I pass as an argument so that I get array printed as an output? Now to have a string completely printed, what should I be passing? To have a string completely printed, what should I be passing? Come on. To have a string printed, what should I be passing as an argument? Okay. Cap backslash n, that is selective scanf. That is to read, Saurabh. So that is a selective scanf to read the string from the user. I'm not talking about string. Assume there is a character. Okay, answer this. There is a character array called str. Okay, let's assume it is initialized with 10 and I have it returned with array like this. So to the printf percentage yes, what do you pass as an argument? In this, you pass str as an argument. That means what are you actually passing as an argument to the percentage yes? To have the complete string present. Yes, I should pass the base address of the string or one dimensional array's address as a argument so that I will get the complete string printed with the help of percentage yes format specifier. Now pictorial representation, you observe and tell me what should I pass as an argument here to get array printed as an output? Pictorial representation. See, I have to pass. Should I pass yes? I have to pass the address 1000, isn't it? So I have to pass the address 1000, which should be the base address of the first one-dimensional array. How to get the base address of the first one-dimensional array? So I should pass yes or 0 as an argument. Are you able to follow this? I should give the base address of the one-dimensional array. So I should pass yes of 0 as an argument. Similarly, to get off printed as an output, I should pass yes of 2 as an yes of 1 and yes of 2 to get strings printed as an output. So what is compiler seeing this as? It is a two-dimensional array. You should not forget. So it is star of yes plus 1. What is pointer arithmetic dependent on? I am performing the pointer arithmetic for the very first time. And yes is a two-dimensional array. So what is pointer arithmetic dependent on? Come on. Remember the table we wrote yesterday? In case of two-dimensional array, is it size of pointer? It is the size of one-dimensional array. See, in two-dimensional array, if a 2D array is dereferenced for the first time, we get the base address of 1D array. Hence, before dereferencing, if pointer arithmetic is applied, it depends on size of one-dimensional array. So what is it dependent on? Size of one-dimensional array. Okay, 1 multiplied by size of 1D array. How much is size of 1D array in this case? Yes, it is 8 because every array has 8 columns. So it is star of, yes is the name of the array which is representing the whole address of the array, plus 1 multiplied by 8, it is star of 1008. Now if I dereference the 2D array for the first time, if I do star of 1008, what should I get? If I give 1008, yes, I should get 1008 back. So percentage yes equivalent of it gives me off printed as an output. Similarly for the strings also. Are you able to follow this? Are you able to follow this? Please respond. Okay. If you got this, answer me one more question. What format specifier do I use to print a character? What is the format specifier to print a character? Okay, it's %C. Okay. Now, to the printf %C, I have to pass something as an argument, and this printf should basically print me character n. So I am talking about this character n. So it should print this character n. Tell me what should I pass as an argument to the printf function? Yes of 2 of 4. Okay, what about others? Two of 4. Okay. Now, if I take yes of 2 of 4, let us check if this is working fine. So what is compiler seeing it as? Star of, again one more star of yes plus 2 plus 4. So here plus 2, first time I'm performing the pointer arithmetic. So it depends on size of one dimensional array. Next, second time I'm performing the pointer arithmetic. After dereferencing, I'm performing the pointer arithmetic again. So it depends on size of the data type. Okay. Now it is star of yes is representing 1000 plus 2 multiplied by size of 1D array is 8. Okay. Plus 4 multiplied by 1. Next, it is star of 1016 plus 4. So if I dereference 1016, what should I get? 1016 is representing the outer address of this 2D array. So I have to dereference, I get 1016 back. To that I'm adding 4. So it is 20. So if I dereference address 1020, I should get character n. Okay, so that is character n. Next, can I do str of 1 of 2 with character f like this? Is it possible for me to do yes of 1 of 2? So yes, so here I can go and have a character f written. Okay, it is anyways a modifiable string. So you can modify the contents of the string anytime, because the memory for the modifiable string has got allocated in the stack segment, because I have taken it as a local variable. So modifying it is allowed. Understood this example? Okay. So you can see percentage yes equivalent of yes of 0 should give arrays printed. Percentage yes equivalent of yes of 1 should give off printed, and percentage yes equivalent of yes of 2 should give me strings printed as an output. Okay. So that is about the array of strings. Now one more example, one more way of taking array of strings is with the help of array of pointers. So assume I want to store 3 strings. So I take character pointer yes of size 3. I want to store 3 characters addresses. So I took yes of size 3. Now how many bytes of memory is allocated for yes? If it is a 64-bit system. So consider it as a 64-bit system. How many bytes of memory is allocated for yes? Yes, so it is 24 bytes. Now this is yes. Assume it is from the address 1000. Then this is 1008 and this is 1016. Now what can I store inside this yes? What can I store inside this yes? I can store the addresses. Now I want to take the array of characters. I mean, I want to take the strings, individual strings, and I want to get it stored inside this. So what I will do is, inside this, I will initialize as array, okay, then of, then strings like this. Okay, we do something like this. Now tell me, this yes is an array of pointers which can store only addresses inside this. Can I write array here? Can I write array here? Is it possible for me to have an array return like this? No. Then where do you think is the string present? Where do you think is the string present? Where will be the string present if I cannot have array return like this? It is very similar to this. Char star str is equal to array. So where will be array present in this situation? Yes, it is going to store the address in 1000, correct? So where is the string present? Yes. So the string should be present in the code segment. So somewhere in the code segment, you should have your strings present. I'll write the string vertically. So array, okay, array with a null character. So that it will be present. Then its base address, let's say it is present in the address 500. That 500 will be held inside this pointer variable. Then off will be taken with the null character. Assume it is present in the address 600. It is stored here. Then strings, strings with the null character will be present. Let's say in the address 700. So 700 will be stored here. And after that, the pointers will be pointing to the addresses. Now, after this, if I want to get the string present, what should I pass as an argument to percentage yes? If I want the string present, let's say array as an output should be printed. So what should I pass as an argument to percentage yes? Come on. What should I pass as an argument to percentage yes to have array printed here? Pictorially, if you see, what should be passed? Okay, different answers. Let me tell you what happens in each of the scenario. So first one is giving star yes of 0. One answer I got. One more answer I've got is star of yes of 3. I don't know why yes of 3. Then there is double star yes of 0. I got these answers. Now let us understand what is happening here. First of all, what is yes? Yes is actually a array of pointers. Okay. Yes is actually a array of pointers. Now if you say star of, one second, let me remove this off, and this one, I'll write it here. Okay. When I say star yes of 0, so it is star of yes plus 0. One more star is there. Am I right? So if I say star yes of 0, yes of 0 will be seen as star of yes plus 0. The one star I retain as it is. Now what is happening in this case is double star. Yes is representing the base address of the array, which is 1000 plus 0. In case of array of pointers, okay, in case of array of pointers, first time pointer arithmetic depends on what? Size of, yes, it is size of pointer, okay, which is 4 or 8 depending on the bitness of the system. Now whether it is 4 or 8, because I'm multiplying with 0, let me ignore. So double star of 1000. What will one star of 1000 give me? What will one star of 1000 give me? It gives me 500. Okay. So now another star of 500. Another star of 500. It is a character pointer. Okay. It gives me one character only. 500 is like the address. Dereferencing that gives me the character A. So instead, to the percentage, yes, I have to pass just 500 as an argument. So what should I pass? To pass just 500 as an argument to percentage, yes, what should I pass? Don't you think before dereferencing I have to pass? Yes, it is just yes of 0. Percentage yes equivalent of yes of 0 gives me array printed as an output. Now if you take this scenario, actually this gives me a compile time error, because yes will be allowed only to dereference twice. A maximum number of dereferencing you can do on yes is twice. Here you are trying to dereference thrice. So compiler gives you a error at the compile time itself. So these two are wrong. This one is also wrong. To get character A, it is fine. But to get the complete string, you have to pass yes of 0 as an argument. Are you able to follow this? Okay. So percentage yes equivalent of yes of 0 gives me array printed. Percentage yes equivalent of yes of 1 represents address 600, which gives off printed as an output. Percentage yes equivalent of yes of 2 represents the address 700. So it has to give strings printed as an output. Next, can I do yes of 1 of 2 in this case with character F? Is it allowed? Yes of 1 of 2. Is it allowed for me to do it like this? No. What is the reason for no? Yes. So yes of 1 of 2. So yes of 1 is representing 600. Of 2 is representing this position. I want that position to be written with character F. But if you look at the example, the string is actually present in the code segment, which is read-only segment. Attempting to make any changes into the code segment should give you an error. So this gives you a runtime error called as the segmentation fault. So because it's a constant string, you can see yes of 0 is initialized with array, yes of 1 is initialized with off, yes of 2 is initialized with strings. So yes of 0 represents the address 1000. Percentage yes equivalent gives all the characters till it reaches the null character. So array will be printed. Now percentage yes equivalent of yes of 1. So it is 1010. Percentage yes equivalent of 1010 gives me off printed. And percentage yes equivalent of 1020 gives me things printed as an output. Understood? Ma'am, please explain once again how yes of 0 gives an array. Okay. See, whenever you have to print a string, With the help of %s format specifier, you just have to provide the starting address of the string. Okay, you just have to provide the address 1000 to the string. So %s format specifier prints all the characters from the address you have provided. Now, if you take this example, okay, yes is an array. It is an array of pointers. So yes of 0 is this, and yes of 1 is this, and this is yes of 2. Okay. Now yes of 0 represents the address 500. If I give address 500 to the %s format specifier, it prints all the characters till there is a null character. So it will give array printed as an output. Understood? Yes of 0 of 1. Yes of 0 of 1 gives R. Yes, it is. So it gives R. Yes of 0 of 1. Yes, it gives R. Okay. Fine. So that was about array of strings. The second thing in case of multi-level pointers. Now, if you look at this, there is a class work for you to do. And I think you have the access in Moodle to submit your classwork, right? Okay. So all of the classwork so far been given, you can submit there itself. You don't have to personally send it to me. You can submit there itself. Okay. I was not aware that your batch had been added there. So today I just checked. So you can submit your classwork there itself. You don't have to send it to me in person. So there is one more classwork here on array of strings to be written. Write a program to print menu and select an option. Okay, and this is the prototype of the print menu function. So it is taking character second level pointer called menu as an argument. So please listen what you have to do here in the classwork. In the main function, you have to take array of strings, return with these 5 strings: file, edit, view, insert, help. Okay, in the main function, you have to take array of strings initialized with 5 strings: file, edit, view, insert, and help. Now that string should be passed as an argument to the print menu function. That array of strings has to be passed as an argument to the print menu function, and you are collecting it with the help of character second level pointer. Now being in that function, you have to display the strings with the option number like this. So 1 for file, 2 for edit, 3 for view, 4 for insert, and 5 for help. So being in the print menu function, you have to display the menu along with the option number, and you are supposed to ask the user to enter the option number. Okay, you are supposed to ask the user to enter the option number. You in fact are supposed to do a validation also. User has to enter the option number from 1 to 5 itself. So if he enters any other number than 1 to 5, you can throw an error. Okay, that validation is optional. So if you assume user is going to enter numbers between 1 to 5, then you don't have to do the validation. Okay, it is completely up to you, but a good practice to do the validation also. So first you have to ask the user, enter the option, and depending on the user's option, you have to print which menu the user has selected. Okay, all of these operations you have to do it in the function called print menu, but the strings array of strings should be taken in the main function. Understood? So give this classwork a try and submit it in your Moodle itself. Okay, that is a classwork on array of strings. So Associated to array of strings, there is something called as command line arguments also. So command line arguments are a part of array of strings itself. The concept applies there also. And command line arguments is something we will discuss in functions part 2 chapter. Okay, so we will revisit array of strings concept again in functions part 2 chapter when we are about to discuss command line arguments. So that is it about the second type, which is nothing but array of pointers. The next we have got to start is pointer to an array, another type of pointer. So before I start another type of pointer, I'm just giving you 2 minutes of break. If you want, you can note this down. Okay, can we continue? Fine. So proceeding ahead, the next pointer we have got to discuss is nothing but pointer to an array. Now what is this pointer to an array is? This is a special type of pointer which is specially meant to store the address of an array. Okay, rather than storing the other addresses, it is specially meant to store the address of an array itself. Now you must be thinking you already had a pointer which was capable of storing the address of the array. Yes or no? So assume I had an integer array called ARR of size 5 initialized with 10, 20, 30, 40 and 50. Okay. Now I want a pointer variable to be taken like this, which was storing the base address of the array. Don't you think this was possible before this? Was it not possible to have things taken like this? Yes, it was there. So it was all fine to have the base address of the array stored inside a pointer variable. But this time, see, what happens is when it comes to a one-dimensional array, okay, when I was passing a one-dimensional array from one function to another function. So if you take an array like this, int ARR of size 5. So assume I was performing something like ARR plus I, okay, and I was dereferencing. So is this possible or not? Can I do this or not? Star of ARR plus I. Yes, I can do. So when I say ARR of 2, compiler is anyway seeing it as star of ARR plus 2. So what was pointer arithmetic actually depending on? What was pointer arithmetic depending on? If I dereference ARR, I was getting an integer. So pointer arithmetic was dependent on size of, don't you think it was the data type? Yes. So it was size of data type. Now, whenever I was passing the name of the array as an argument from one function to another function, I used a single level pointer to collect that base address, because in case of array, pointer arithmetic was dependent on size of data type. In a single level pointer also, pointer arithmetic was dependent on size of data type. So I had a pointer which was capable of doing the operation same as that of an array. Hence, we didn't have any problem. Now look at the two-dimensional array. First time pointer arithmetic on a two-dimensional array depends on size of one-dimensional array. Second time pointer arithmetic depends on size of the data type. Do I have any pointer which does the operation same like this? Do I have any pointer variable where pointer arithmetic depends on size of 1D array? See, you know array of pointers, you know second level pointers. In both of the cases, pointer arithmetic was never dependent on size of 1D array. Okay, so I hope you are getting my point. Hence, whenever you had to pass a 2D array from one function to another function, you need a special type of pointer called as pointer to an array. Okay, so I need a special type of pointer called as pointer to an array. Now see, there is an integer array called ARR of size 3 initialized with 1, 2 and 3. There is an integer pointer called PTR. So inside PTR, I'm storing array as an argument. Now I'm calling the printf function and I'm passing star PTR as an argument. Look at this and tell me what should this give me as an output? It has to give me 1 because I'm storing the base address of the array into the pointer variable. If I dereference, I have to get the first integer, which is 1. It was fine. Now, how to take pointer to an array is the question. If I just write something like this, I write int star PTR of size 3. So what is this? What concept is this if I write int star ptr of size 3? Yes, so this is array of pointers. Now in order to make this a pointer to an array, you have to write the pointer inside a parenthesis like this. Now how do you read this is ptr is a pointer to an array of 3 integers. Okay, so 3 integers. ptr is a pointer to an array of 3 integers. Now this pointer to an array is a special pointer which is meant for a two-dimensional array. Now if I have to do it on a one-dimensional array, there is a problem. See what happens here. Array represents what? Just the name of the array represents what? It represents the base address of the array. I am storing that base address into the pointer variable ptr. Now, if I dereference that base address for first time, what will I get? If I dereference that base address for the first time, I get 1. Now, because it is a pointer to an array, I'm supposed to dereference it for 2 times. Now, if I dereference it for one more time, what do I end up getting? I will get an error. It gives me a segmentation fault. First time dereferencing itself gives me 1. If I dereference it for another time, I will get an error scene, isn't it? Don't I get an error scene? Okay. Now, how do you think I can solve this problem? How do you think I can solve this problem? Think. We took one-dimensional array and I want to represent the whole address of the array. So how to represent the whole address of the array? In case of one-dimensional array, how to get the whole address of the array? Come on. How can I get the whole address of the array in a one-dimensional array? With the name of the array. I should be using something else. Yes, it is address of ARR. Okay. Yes, it is address of ARR. Now see what is happening. First, this is an array of 3 integers. Okay, this is an array of 3 integers. Now, assume the starting address is 1000. Okay, this is 1000. And this is having 10 stored inside it. This has 20 stored inside it. And this has 30 stored inside it. Okay. Name of the array is representing the base address or the starting address initially. Now, if I take the whole address of the array, okay, it is ampersand of the array. Now, what happens? I'm treating this whole array as one big variable and its starting, sorry. Okay. And its starting address is 1000. Okay, this starting address is 1000. Now what happens is when I dereference, okay, for 2 times. So first it is star of 1000. PTR is having 1000 stored, the outer address stored. Now if I dereference 1000 for the first time, I'm at the outer address. What do I get if I dereference 1000 for the first time? Yes, I get 1000 back. Now if I dereference 1000, what will I get? I should get the value 10. So if I want array of pointers to be treated as, if you want pointer to an array to be used in a one-dimensional array, consider the whole array as a one big variable, okay, and store its base address into the pointer variable. So that is how you make pointer to an array work with the one-dimensional array. Understood this? Okay. Now see, as I said, The special reason for using the pointer to an array is for a concept of two-dimensional array. Now, before that, let us consider this example. But array and address of array is same no for 1D array. So if you have not forgotten, we saw the difference between array and address of array when we were doing the pointer arithmetic in arrays interpretation. Let me take you there. Here, did we not discuss what is the difference between array and address of a? So if you do a plus 1, it depends on size of data type. If you do address of a plus 1, what was it dependent on? Yes, the name of the array here is representing the whole address of the array, and it depends on size of the array. Okay, so that difference is helping us out here in the pointer to an arrays concept. Numerically, they both represent the same value, okay, but not technically. So technically, the pointer arithmetic depends on two different factors. Are you able to follow this? Okay, fine. Now proceeding ahead, see, I have taken an array of size 3 with 3 integers 1, 2 and 3. I've taken a pointer variable called P1. I have taken a pointer to an array called P2. Okay, and 3 here is representing the number of columns in the one-dimensional array. Now into P1 I'm storing name of the array, which is representing the base address of the array, which is 1000. Into P2 I'm storing the whole address of the array. It is also representing 1000 numerically. The 1000 is being stored. What happens when I do P1 plus 0 and P2 plus 0? When I do P1 plus 0, pointer arithmetic depends on what? It is just a single level pointer. So pointer arithmetic depends on size of data type, which is 4. And in case of P2, it is a pointer to an array. Okay, an array of 3 integers here. So every time when I do pointer arithmetic, it should point to the next arrays. Hence, pointer arithmetic depends on size of 1D array. How much is the size of 1D array here? It is nothing but, why is that 3? So size of 1D array, it is 12. Okay, the memory allocated for 1D array is 12. So P1 plus 0, P2 plus 0 anyways gives me 1000 itself. P1 plus 1 gives me 1000 plus 4, which is 1004. What does P2 plus 1 give me? What does P2 plus 1 gives me? 1012. Yes. So similarly, P1 plus 2 gives me 1008 and P2 plus 2 gives me 1024. It is pointing to the corresponding arrays. So pointer arithmetic in case of pointer to an array also is same as that of a two-dimensional array. So pointer arithmetic on 1D array is based on size of data type. Pointer arithmetic on 2D array is based on size of data type as well as size of one-dimensional array. You're not getting it? Let me repeat. P1 is a pointer variable, a just integer pointer variable. Hence, pointer arithmetic depends on size of data type. Now, P2 is a pointer to an array of 3 integers. I have taken it is a pointer to an array of 3 integers. So, size of pointer arithmetic on P2 depends on size of an integer of 3 elements. Okay, a 3 integered array. So it depends on size of one-dimensional array, which is 12. Are you able to follow this point? Okay. Now P1 and P2 basically are having the numeric value 1000 stored. So 1000 plus 0 will be 1000. and 1000 plus 0 here will also be 1000. So both of them represents 1000. Now this is P1 plus 1 multiplied by 4, so it is 1004. Okay, this is P1 plus 1 multiplied by 12, which is 1012. It is pointing to the next array. Okay, it is every time pointing to the next one dimensional array. Similarly, when I do P1 plus 2, I should get 1008, and when I do P2 plus 2, I should get 1024 because it is 1000 plus 2 multiplied by 12. So 1024. That is array of pointers. Got it? Okay. Now where this array of, pointer to an array comes into picture is in case of 2D arrays creation, or when you have to allocate the memory dynamically. Now look at this. It is an integer array, okay, of size 3. A pointer is meant to point to that integer array of size 3. Okay, so something like this. I will parallelly take this. Okay, now see, P is a pointer variable. This is P. It is ready to point to an integer array of size 3. Like this, there is an integer array. Okay, so it has a whole address. To this whole address, the pointer points. So this is the pointer variable PTR. Okay, PTR, and it is let's say present in the address 1000. This is in the address 2000, 2004, 2008. Okay, this is the starting address 2000. When I pass this 2000 as an argument to the size of operator, what should it give? Actually not this 2000. I will give this 2000 as an argument to the size of operator. What should it give me? 4 or 8? Why? It is the base address of a one-dimensional array. If you see this 2000, you enter into that. 2000 is the base address of a one-dimensional array. So what should you get as an output? If I pass base address of one-dimensional array to the size of operator, don't you think it gives me the total memory allocated? Yes, it is 12. So here also, when I dereference the pointer for the very first time, I will enter into the corresponding one-dimensional array. So assume it is having 2000 like this. This is just a representation I'm taking. So like this, it will be pointing. If I dereference pointer, okay, PTR is having 2000. If I dereference 2000, I will enter into the inner address. Okay, this inner address of the one-dimensional array, the starting address. So when I do the pointer arithmetic, it should depend on size of one-dimensional array. Okay. Now, how much is size of star P is the question. Please understand, in case of a two-dimensional array, if I dereference first time, I will get the base address of a one-dimensional array. So, when base address of one-dimensional array is passed as an argument to the size of operator, it gives me the total memory allocated for that one-dimensional array. Now think here and tell me how much is the total memory allocated. I have told it is an integer array of size 3. There are 3 integers. So how much should size of star P give me as an output? It should give me 12. Are you able to follow this? Are you able to get why is this giving me a 12? Okay. Now it is 12 multiplied by 3. There is a total of 24 bytes of memory allocated by the pointer variable. Now look at this and tell me in what addresses I will get 1, 2 and 3 printed as an output. Pointer arithmetic on pointer to an array is same as that of a two-dimensional array. Okay, I will copy this. And here I'll paste, but here it is pointer to an array. Int star ptr of size 3. Okay, if a 2D array, if I would say if a pointer to an array is dereferenced for the first time, we get the base address of 1D array. Hence, before dereferencing, if pointer arithmetic is applied, it depends on size of 1D array. After dereferencing once, we have entered the corresponding 1D array. So now after dereferencing once, if pointer arithmetic is applied, then pointer arithmetic depends on size of the data type. Now look at this and tell me in what addresses do I get 1, 2 and 3 return. In what addresses will I get 1, 2 and 3 return? Okay, address 1000. Then what about 2 and 3? 1000, 1016. Okay, and 1032. Okay. So got one answer. What about others? It is okay. C star of P plus 0 of 0. Okay. I will not rephrase this yet. So it is star of, okay, I'll not do it here. Write it here. Okay, it is star of P plus 0 of 0. Okay, now it is star of, what is P representing? P is representing 1000 plus 0 multiplied by size of what? Before dereferencing, I am performing the pointer arithmetic for the very first time. So what does pointer arithmetic depend on? Size of 1D array. And how do you get the size of 1D array in this case? You can look at this pointer to arrays declaration. Okay, it is 12. Yes. So it has to be 12. Of 0, I am retaining it as it is. So here I'll copy, and size of 1D array is 12. Okay. Next, it is star of, oh, I took one more star extra. Okay, fine. So 1000 of 0. Now star of 1000, dereferencing address 1000, what should I get? If I dereference address 1000, it's like a 2D array. So if I dereference address 1000, what should I get? I should get 1000 back. So 1000 of 0. Now it is star of 1000 plus 0. Now tell me, after dereferencing once, I'm performing the pointer arithmetic again. So what does it depend on? Size of? What does it depend on? After dereferencing once, I'm performing the pointer arithmetic. Yes, size of data type, which is integer. So it is star of 1000 plus 0, which is star of 1000. So I have to go to address 1000 and have it return with the value 10. Similarly, change this 0 to 1 and this 0 to 1. So this will be 1000 plus 12, 1012. Dereferencing 1012 gives me 1012 back. Of 1 is 1012 plus 4, so it is 1016. So in 1000 I will have 1 return. In 1016 I will have 2 return. In 1032 I will have 3 return. Similarly, P of 0 gives me 1. P of 1 gives me 2. P of 2 gives me 3. You can see here. Okay. In address 1000 I have 1 return. 1016 I have 2 return. 1032 I have 3 return. Understood this? When will it be dereferenced? Depend on size of pointer. No, after dereferencing, it's a 2D array. It is a kind of 2D array. After dereferencing, what you get is an integer value. Hence, it should depend on size of data type, not the size of the pointer. Okay. So similarly here, see, I have pointer to an array. I have a two-dimensional array of 2 rows and 3 columns. I'm going to store its base address into the pointer to an arrays concept. So P is equal to A. I'm going to store the base address into a the base address of a 2D array into a pointer to an array. Understood this? Okay. So the next we have got is to pass a 2D array from one function to another, and also to declare 2D array in different ways. So I think we will do it in the next session. So today is Saturday. So we will do it in the next session. So here, how to pass a 2D array from one function to another function, and how to declare the different types of two-dimensional arrays. We will do it in tomorrow's session. I mean on Monday's session. Is that fine? Okay. All right. So that is it for today. We could discuss things with respect to array of pointers, array of strings, and pointer to an array. So please remember, you're not forgetting the concepts. If you have got any doubts anytime while revising, please make sure you're pinging me up. Okay. Fine. So let me give you the attendance. Okay. So here is the QR. Please have your attendance marked and quit the session. Ma'am, will you upload the class notes in LMS? You want these notes to be uploaded? Okay, I'll do that. Okay, not an issue. I'll upload the notes. So refer it whenever it is required. Okay, fine. So thank you all. Have your attendance marked and quit. We will continue on Monday.